Hey everybody and welcome back to our YouTube channel.
Today's video is about similar triangles and congruency.
Before we begin, make sure that you like the video and subscribe to the channel.
Keep in mind, as we do the questions in this video, all visuals that you see will not be drawn to scale.
And let's just get right into it.
Question 1 says triangle ABC is similar to triangle DFE. The lengths of BC, AB, DE, and EF are 12, 10, 12, 18 respectively. What is the sum of the perimeters of the triangles? So the correct answer to this question is answer choice A, 75. So we need to make sure our angles are right. So it says triangle ABC is similar to triangle DFE. So angle A and D will have the same measure. Angle B and F will have the same measure. And angle C and E will have the same measure. And then now let's label our lengths. BC is 12. AB is 10. DE is 12. And EF is 18. And so now let's set up some ratios. So we have an ABC is similar to DFE. BC BC over FE. We can set this equal to AB over DF. Plugging in our values, we get 12 over 18 equals 10 over DF. We can call this X. Simplifying and solving for x, we get x equals 15. Similarly, if we do BC over FE is equal to AC over DE, plugging in our values, we can call AC y and DE 12. So we get 12 over 18 is equal to y over 12. Simplifying and solving for y, we get y equals 8. And so now we have the lengths of all our sides, and all we have to do is add them. So the perimeter of this triangle is 30, the perimeter of this triangle is 45, and 30 plus 45 is 75. Question 3 says, lines AB and CD are parallel and contain points W, X, Y, and Z. The ratio of lengths WX to XY is 3/2. If the area of triangle XYZ is 120, what is the area of triangle WXZ? The correct answer is answer choice C, 180. So let's label our lengths. We can call WX 3x, and since the ratio of lengths WX to XY is 3/2, this will make length XY equal to 2x. So we are interested in this triangle and this triangle. And recall that the area of a triangle is 1/2 base times height. We know the bases for each of the triangles, and we know that the height is the same for both of them. So we can call the height h for both of our triangles. So we're given the area of this triangle. We can set our equation 1/2 base times height equals 120. Our base is 2x. Our height is h, and this is equal to 120. So solving for xh, we get x times h equals 120. Now for this triangle, WXZ, we can set up the same equation. 1/2 base times height gives us 1/2. Our base is 3x. Our height is still h, and we know what x times h is. So 3/2 times xh, which is 120, gives us 180. Our last question says rectangle ABCD has a length of 8 and a height of 6. Diagonal BD is drawn. Point E lies on BD such that angle BEC is 90 degrees. What is the length of DE? So let's draw in the given lengths and angles. We have DC is 8. Shoot, why can't I draw? We have DC is 8, BC is 6, and because this is a right angle right here, this makes BD 10, because a squared plus b squared equals c squared. And BEC is 90 degrees, so this is a right angle, which makes this a right angle. So let's find some similar triangles, and we're going to do this by marking down some angles. So we can call EDC alpha. Because angle DEC is 90 degrees, this makes angle ECD 90 minus alpha. And because BCD of the rectangle is 90 degrees, this makes BCE alpha. And because this is a right triangle, BEC, this makes angle B 90 minus alpha. And so now we can start matching up some similar triangles. So angle D has an angle of alpha, so D. We can mark this up with, we can follow this up with angle E, which has 90 degrees, and C, which has an angle of 90 minus alpha. And triangle CEB is similar to triangle DEC because both angles D and C have an angle measure of alpha, E and E have an angle measure of 90, and C and B both have 90 minus alpha. But don't forget that this giant triangle right here also has those angles. So we can correspond this with, these two triangles are similar to triangle ECB. So let's start setting up some ratios. So we can look at this triangle and this triangle. And for reference, that is this triangle right here and this big triangle right here. So we have DC, that's 8 over dB, which is 10, and this equals EC. We can call that X, so this would be X to CB, which would be 6. In solving for X, we get, and simplifying, we get X equals 24 over 5. So we can get rid of that. Say this is 24 over 25, over 5, excuse me. And then now we can look at this triangle right here. Since this is our right triangle, ECD, we just solved for length EC, which is 24 over 5. We know that the hypotenuse DC has a length of 8, and we're asked to solve for DE. We can call that another X, but we can still call it X. So now we can do A squared plus B squared equals C squared. So we have X squared plus 24 over 5 squared is 576 over 25 equals 8 squared, which is 64. This will make X squared equals 64 minus 576 over 25. Putting this all into one fraction, we get 1600 minus 576 over 25. 1600 minus 576 is 1024 over 25, and this is x squared. So when we square root this, we're going to get 32 over 5, which corresponds to 6.4, which should be answer choice D.
Thank you guys so much for watching a 5th math topic video.
Make sure to like this video if you learned something new and subscribe to our channel if you enjoy watching our videos.
We'll see you guys next time. Bye!